All right, now we're recording. Welcome YouTube, welcome subscribers, all four of you.
Dude,
Um,
smash that like button.
yeah, so last episode we talked about CleanRL getting Doug all set up. Now he's experiencing some bugs, but we'll get to that. We'll get to that later. I wanted to spend a lot of this episode on kind of like what is reinforcement learning. Uh, I won't like get too into like the details and the specifics of it. I just want you, Doug, to like get a general like understanding of it.
Oh, goodness.
Yeah, it's not going to be like some math class. I said
Dang,
math, not meth, but
I like math.
uh, I think that I'll share my screen like at some points.
Yeah, that works.
Uh, in
Have some
fact,
visual of some sort.
in fact, I can go ahead and just share this Mario. Do you see it?
Heck yeah. Yeah, I see
Okay,
Agent
cool.
Mario in the environment.
Yeah.
Mhm.
Um, yeah, so I guess like just some like background. So, okay. So reinforcement learning is this it's under this umbrella of machine learning. So
Mhm.
we're talking about like AI, everything's AI. So yeah, so RL is just a type of machine learning.
Mhm.
And you essentially have this thing called an agent. And it's basically learning to make like optimal decisions by interacting with some sort of environment,
An
right? So
agent's the controllable entity, right?
yeah,
Okay.
the agent is the one that is making the decision.
Mhm.
So
So
if
like
it's yeah, go ahead.
so like a Goomba isn't an agent. Like
No,
Mario would be the
Mario
only
would be the
agent.
agent.
And
Yeah.
then is Goomba environment or is Goomba
Yeah, Goomba is
separate?
part of the environment. And it might even be a part of the state.
Mhm.
So just to
Oh, yep.
yeah, so basically like I don't know if you were playing a game like Tetris or something like that, right? So the goal is to perform actions that maximize like some sort of cumulative score like over time,
Mhm.
right?
Yep.
So if it's Tetris, then the goal is to maximize the I guess the blocks, the positions,
Mhm.
rotating them in the falling shapes into like the lines to clear the lines so
Mhm.
that the screen doesn't fill up, right?
Mhm.
So the more lines cleared, the higher the score, the more reward you have.
Mhm.
Um, if it's a little bit more complicated of a game like Mario Kart, then I guess like different objectives can do different things, but one thing would be trying to complete laps in the shortest amount of time, or you
Mhm.
could optimize for like finishing like in first place, which they sound like the same thing, but
Mhm.
like in reality not really, because if you just it's the same thing with like the stocks, right? If you optimize for a winning percentage and all you have to do is win, then it's just going to do the least amount of work to win. So similarly, like with Mario Kart, like if you're optimizing for the shortest amount of time versus just get in first place, you
Mhm.
could you could get into first place but still not have that great of a racing time.
Right,
Um,
yeah.
um, and
It's
so
playing others versus playing yourself.
yeah, exactly. And you actually see that with a lot of different examples. And I think over time, like different games evolve with different techniques on what people should be optimizing for.
Mhm.
Um, a lot of the papers that I read, like with stocks, they'll optimize for profit and just profit alone. And maybe that's not the best way. Maybe you want to find like some sort of metric that optimizes for profit and manages risk, like the
Mhm.
combination of the two.
Mhm.
Um, but yeah, it doesn't always have to be profit. But basically, like these games or kind of whatever you're doing, the agent learns by experimenting with all the
Mhm.
different actions that it has at its arsenal.
Mhm.
And essentially it'll take an action, observe some sort of like outcome, and then over time through like trial and error, it'll identify like patterns and strategies that will hopefully yield a really high return. So in this image here, and I actually like this image because uh, a lot of the diagrams on like Google and stuff aren't like the best. So I like that it gives like the Mario kind of example, but
Yeah.
you see it, right?
Mhm.
Yeah. Okay. So you have an agent, and the agent is like the learner and
Mhm.
the decision maker. So again, if it's stock trading, the agent is the one that buys, holds, or sells. If it's Mario,
Mhm.
then it's Mario. If it's Pong, then it's the controller of the
Mhm.
thing.
Yeah.
And then you have this environment that it's interacting with, um, which for stocks, it would be like all the information that you could possibly find that involves the stock market, which is not
Uh,
technically like possible. So you kind of have to like do your
so like
best
two or
to,
three things. Yeah.
yeah, yeah.
Yeah. Yeah.
I mean, a lot of people find like, obviously the stock prices, but they find like, I don't know, maybe macroeconomic variables,
Mhm.
um, tweets, news sources, anything that
For a while,
has,
tweets ran the stock market. So yeah, that makes sense.
yeah. And even still now, I mean,
Dogecoin to the moon, dude.
yeah, hey, GameStop, you invested? Uh,
Is it
but
still? Did it crash? Like it crashed again, right?
I don't know. I didn't
Oh,
watch
okay. I
it, but
was gonna say
yeah.
Reddit usually moves on after a little bit. That was Reddit, right?
It was probably a combination of Reddit and Twitter. I
People are
know,
crazy.
I
People
know
are
with
wonderful,
like,
but people are crazy. You get
yeah,
herd like a
herding
herd of
mentality.
anything, it's crazy.
Yeah. Yeah. 2020 was a wild
The
time
yeah, the
for, especially with like Tesla and
I
stuff.
know. The power of groups is
Yeah.
wild.
Yeah. And I mean, even not even just with stocks, but with like banking and stuff. That's how
Yeah.
that one bank failed. I
Yeah,
think it was
Silicon Valley.
Silicon Valley Bank.
Yeah.
No, it's crazy like how fast things spread. And so
Yeah.
going back to like reinforcement learning, that's why like people, if they're looking at trading reinforcement learning models, they'll use like tweets, or news articles, stuff like that. And that gets into like the states. So state right
Mhm.
here. So the state is like, different situations or features or configurations that the environment can be in. So like essentially like for stocks or a game, it's the information that the agent has at the current time to make whatever action, right?
Okay.
So with stocks, like if we're looking at today, then the state would be like the stock price of today, the what's going on in Twitter for today, what's going on in news articles for
Dude,
today
dude.
at
X.
time. Huh?
X.
X. Actually T.
What? Is it T?
Well, time, yeah.
Oh, no, no, like no, not Twitter. The
Oh,
X.
yeah, X, sorry.
Yeah.
Yeah. Just in
Someone
case people were
yeah, yeah,
confused.
yeah. Sorry. The streamer I watch every once in a while, he'll be like, guys, I'm sorry. Um,
Yeah.
no, but what was it? Oh yeah, sorry. Another offshoot. I was asking about that. I'm like, what do they call tweets now? And they're like X's, and I'm like, I got too many of those. I don't need more of those. I'm good.
Yeah. No, I
You
don't
know
think I'll
me,
ever
ladies man.
actually call it like X,
Yeah.
but I guess in paper writing you kind of have to. But yeah, so all right, so agent sees the states at time t. So like
Hey,
stocks.
there are a few more variables on this page than the other
Oh yeah,
page.
yeah, yeah. Ignore,
I'm
ignore
like, you
critics.
went from like two to like seven.
I just like this diagram.
It's nice. So is an actor an agent?
Yes,
They
yeah.
like that name is synonymous. Okay. Actor
Sorry,
loss,
sorry.
critic loss.
Actor and critic are something else. So just
Oh,
ignore
wait.
those for right now.
Okay, so where is
I don't think there's a box on here for agent. I think you
okay.
just assume that the agent is the one
Is
that's making the
performing the
actions.
actions. Okay,
Yeah.
never mind. Sorry.
So we can ignore critic, Q value,
I ignore
actor,
most
actor loss.
critics.
Yeah, hey,
Yeah.
you might as well.
Smash that like button.
But this is to kind of like show like what the environment is going to have. The environment's going to have all of the stock data that you have, the financial news, sentiment, whatever. And it's across time. So like a state is the information that you have like at its current time. Um,
The
and
state
then
is always the current time, or the state is the
yeah,
time frame.
yeah, here I can show you.
Okay.
So if we had this like Excel for like, I don't know, GameStop prices. So if
Yep.
let's say their closing prices of today was 100, the
One
next
million
day
dollars.
was 111, and you just kept it going.
Mhm.
And let's say that this was like day one. Let's say that they had a sentiment score. Let's say that today's sentiment score was like really positive, so 0.99.
Hey,
Let's
I
say
obviously I know what a sentiment score is, but for the everybody else here, can you please tell me what a sentiment score is?
yeah. So there's lots of ways of calculating. So in just a basic form,
Mhm.
it's basically like the mood of like investors' sentiment towards a particular event or stock. So like if
Oh,
people
okay.
are like tweeting like buy GameStop,
Hmm.
GameStop's going to the moon,
Hmm.
everybody get on GameStop, or like specific things about GameStop that happen that is like good news,
Hmm.
then it's gonna have a higher sentiment. But
Gotcha. Is
the
it always
way
out of one?
no, so
Okay.
there's lots of so I personally think that sentiment scoring is not the most accurate, but a lot of people use it. And I'm
Mhm.
just using it as an example,
Yeah.
but just because a lot of like financial language uh is not perfectly captured in a lot of like the sentiment models out there. Like if I say like Tesla's going to the moon, exclamation point in all caps with emojis,
Hmm.
rocket emojis, there's
Yeah.
very
Yeah.
few like sentiment models that would understand that that's a good thing. There are sentiment models that understand the use of like capitalization and emojis,
Hmm.
but the phrasing going to the moon is it
Right.
might
Foreign.
not. Yeah. I mean, there might be some that have a lot of strengths towards that, but then it'll
Hmm.
have a weakness towards, something else.
Hmm.
But okay, if we had GameStop prices, sentiment, and then let's say like their sentiment like went down and then their stock price went down. So this is like the state right here. So
Hmm.
at day one, when the agent sees or when the agent is in its environment,
Hmm.
all it sees is this and
Right.
it makes an action. And then it goes to the next state and it sees this and it makes an action and it records the reward. And the action is going to be, do I buy it? You can choose your actions. You could have
Hmm.
it do nothing. You could have
Hmm.
it buy. You could have it hold if it's already bought. And then selling as well. Like
Hmm.
everything is like you create it. If it's like a stock environment, if it's like Pong or Mario, those actions are kind of already created.
Hmm.
So you just kind of do whatever the game actually is.
Yeah. I
Um,
mean, it's still left, right, stay put. So it's
yeah,
very similar to a buy, sell, stay.
yeah. And like for stock prices, like you see like kind of a tabular form of data here. Not
Hmm.
always, but um, again, it's very flexible. You
Hmm.
could have like the tabular form with the columns of prices. I've read papers where they've taken images of candlestick patterns as their data. So instead of just like a column of prices, they just have like an image and they process the image and it's
Hmm.
just the candlestick patterns in it. And the agent just trades based off of that, which is
Jeez.
pretty interesting. But
That's cool.
like if it's like a game though, then it's gonna or with the stock candlestick images, it doesn't see like obviously how we see it. So like
Hmm.
if this was like Mario, then it's gonna see like the pixels. I don't
Hmm.
know if you've ever so like RGB. I'm sure you've heard of that, right?
Yeah. 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 I
Yeah.
deal with
So
that occasionally. Not a lot.
yeah. So so if you were to picture this as Mario, right?
Hmm.
It's not seeing the way that we see the game, like in the first episode when we're watching,
Yeah.
the Blastoid or I can't
Hmm.
remember what game
Hmm.
we were shown.
Yeah.
We're actually seeing it
Charmander.
like
Yeah.
right, actually seeing it like rendered, but the model itself is just going to see a bunch of numbers and arrays and vectors and matrices. So,
Hmm.
um, but I will say that like some environments are like much harder to learn than others. So
Sure.
this has to do with learning the environment and the complexity of the actions.
Hmm.
Um, like the games we were playing in the last episode, it's like up, down, left, right, and jump.
Hmm.
But some environments, like driving a car, might be more of like a continuous decision, right? You're not,
Nah, I hit the guardrail all the time.
oh, you do? Yeah.
Yeah.
You're
It's
pressing
it's
the
I only
keyboard
make
on
a
your car.
decision when I'm driving a car maybe once every 5 seconds.
But it's like, it's not like with a car, it's like you're not just going left or right. It's a
Hmm.
continuous like
Yeah, yeah.
curving
Transition.
of yeah, exactly.
Yep.
Um, but
Well,
and
and in
then
that case, could you tell it to incrementally change?
yeah, so there's different like models that handle like discrete actions
Hmm.
versus continuous actions.
Because like
Um,
what asteroids has a full like your agent can go in 360
yeah,
degrees, but you're not going either 0 90, hey, 180, 270, or 360. Hey, I remember the the increments of 90 barely.
yeah,
But like asteroids would need incremental changes and not just up, down, left, right. Um,
yeah,
so I didn't know how easy it is to implement that, or if asteroids is not on the table for us right now.
yeah. I mean, I know like a lot of the games that we'll be messing with will be pretty simple
Yeah.
and we'll probably have a pretty like predictable like environment
Mm.
because essentially everything is known about that environment. Like with Pong, there's not going to be some, you know, random
Yeah, you
like,
can't go forwards or backwards. You can only go
well,
up down.
not even just with the actions. Like it's like Pong, like the game is a
Mm.
ball going like that.
Yeah.
Okay, nothing's unpredictable is gonna happen. Like
Hmm.
Mario's not gonna pop out of the Pong game, and then the agent has
Not
to.
yet.
That's true until we
Yeah.
make that. Stay
Crossover.
tuned for episode 3.
Yeah, the crossover nobody expected. Move away,
Confusing
Marvel and
RL
DC.
agents.
Pong
Yeah,
and Mario.
but it's like everything is essentially like repeated, like in terms of like the scenarios.
Hmm.
So, like, okay, Tetris, like the agent has almost seen like every scenario that could probably ever happen. Maybe not like every combination, but it's gonna
Right,
know like
close
all
to
the
it.
pieces. It's gonna know like, you can turn the piece.
Hmm.
It's gonna understand to put them and to create a line. But for something
Hmm.
for like the stock market, it's so random and unpredictable. There's so many things that
Yeah,
could
it can go
happen,
into it.
yeah,
Yeah.
that it's never seen before,
Hmm.
right? So the other thing is like,
It's my hair sticking out.
yeah, no, you're fine. The other thing is like the games we're playing, they're pretty, I mean, they're 100% representative of the real world game because
Yeah.
it is the game. Like
Yeah.
it just is. But with stocks, like it's impossible to perfectly like simulate a stock market environment.
So far.
True. Stay tuned to
We
episode
could make
4.
that game.
What game?
We can make the stock market game.
Okay. Yeah, let's do it.
Yeah.
Um, but uh yeah, and you have to be really careful about like the features that you put into your agent because you might put in too few and you kind of overfit it to like your data. But
Hmm.
then when it comes to like the real world, like it's not going to do so well because all you did was train it on Elon Musk's tweets and
It's the
the
only thing
stock
you need to
prices.
trade on.
Yeah, good luck with that.
Yeah.
Um, but so basically, how this whole thing works is trial and error. So the agent tries different actions, learns from the results. There's a
Hmm.
feedback loop. So after every action, the agent receives a reward, either positive or negative,
Hmm.
and observes a new state. There's the policy, which is the strategy. So over time, the agent will develop this sort of strategy to decide the best action to take in each state. And then different models do different things. You have this thing where it's like exploring versus exploiting. So do I take the immediate reward now?
Hmm.
Which some games we play on the Atari games will have like an immediate reward, but that's not the grand like strategy of the whole game that will
Yeah,
basically get you
yeah,
the
yeah.
win.
You can stick a Tetris piece into a one block and complete the
Yeah,
first thing, or you can wait and
yeah. Or like
yep.
Mario Kart, there's like little coins around.
Hmm.
Like you still get something from that, but you might not. I mean, you want to win the game or at
Yeah.
least, beat the fastest record. So
You might be
yeah.
getting to this. What is critic and what is actor then?
I'm not gonna go over that
Okay.
right now because those things are a particular type of reinforcement learning
Gotcha.
model
Okay.
as opposed to like what is reinforcement learning as like a general.
Episode 3.
Actually, so I don't know if I'll get into actor critic, but I do want
Mhm.
to go into like some of the models that are in CleanRL.
Okay.
Um, and maybe hopefully explain, especially like some of the parameters and like what they do. But
Yeah.
um, but yeah, so the agent's got to balance exploring, failing, learning, and
Mhm.
it's got to fail so that it can learn.
Right.
It's it's got to run into the turtle thing or
Yeah.
jump on top of the turtle thing and then figure out, oh, I could hit its shell and it
Hmm.
kills people. Like it that you want it to like explore and just make random decisions at first
Yeah. If
and
it
then
doesn't have
get there.
negative reinforcement, then
Yeah.
it doesn't know to avoid it. Yep.
Yeah. So essentially there's lots of different kinds. Here, let me pull up. Let's see. So essentially, there's lots of different kinds of reinforcement learning
Hmm.
algorithms. Um, we're not going to spend a whole lot of time on them. I know that we're almost out of time with the remaining meeting. So let me
Oh,
go
that's
through this
true.
really fast,
Yeah.
and then we could wrap up. But
Okay.
so you see you see my screen?
Yep.
Okay, so you see like
I
the
see the
diagram.
tree.
Okay,
Yep.
so these are probably like the most like foundational designs choices for reinforcement learning algorithms.
Okay.
Um, you'll basically see like it breaks up into two. main branches. So there's model
Hmm.
free and then model based reinforcement learning. So you could
Hmm.
think of model free as like when you first learn how to ride a bike, and it's basically like what I've been talking about this whole time with trial and error, right? You get
Hmm.
on the bike, you try to pedal, you probably fall uh, multiple times,
Still
right?
do. Yep.
Still do.
On the stationary bike. Continue.
On the Peloton.
Yeah.
But then like with practice, some of us, get the hang of it, right? And
Hmm.
that's essentially what I've been talking about this whole time. Model
Yep.
free is learning by doing without like a model of how to ride a bike, right? You're just making a decision and then changing based off of the reward. Um, and then you have under model free. So actually with the model base, we won't really kind of touch on
Hmm.
just because it's a little bit more difficult and it's not really relatable to CleanRL. Um, but under model free, you have policy optimization
Hmm.
and Q learning. So policy optimization is you have like this update to your policy, which is the strategy, but you're only using the data collected from the most recent version of the policy. So
Hmm.
this basically means that it's applying all the lessons learned throughout the training process,
Hmm.
and it's directly optimizing for the thing that you want. And then Q learning updates using data collected at any point during the training. So regardless of how the agent was choosing to explore the environments when the data was obtained, it's indirectly optimizing for the agent performance. So in other words, policy optimization is like if you were to be cooking, right,
Hmm.
improving a recipe, you're tasting the dish after each like small change you make
Hmm.
directly, right? You adjust the ingredients after you taste, and the adjustment is the actions, and then the taste is like the reward to make the dish better. So it's like incrementally like right now, like if that kind of makes sense. And then Q learning would be like you have a cookbook where you keep notes on like previous ingredient combinations and how well it did. And instead of tasting every time, you look at your notes and decide like what ingredients might make the dish better in the future. So you're not changing anything from a direct like feedback loop, but you're all
Heck
right.
yeah.
So got the recording going again. I don't know where. I guess like I could kind of like recap like
Yeah, that works.
so I mean we're talking about model free versus model based.
Yeah. Can you share your screen?
Yeah.
I love your face, but I mean, I want to see this model again or this diagram. Sorry, I kept asking questions. I forgot we were on a time.
Oh no, no, no. You were fine. When we were at like 4 minutes left, you were fine. I forgot like how much I was like gonna be saying. I
No, you're
forgot
good.
like I was going into like kind of this diagram, but
You're good. Well, okay, so now that we've got time, I do want to ask the question.
yeah,
Does Q learning or policy optimization never become model-based RL? Like is model-based RL just from the beginning? Because it almost seems like a model is formed through either policy optimization or Q learning for future iterations of that learning process. Like so they have something to build off of, but is that not called a model at that point? It's just continuously uh nested under policy optimization or Q learning. It's never
yeah.
considered a model.
I mean, you're technically building a model like from scratch, like with
That's what I
the
was wondering. Yeah,
yeah
because I've seen like
versus
I've seen Q learning with there's like a race car, go down the path and it like the car finally makes it to back to the starting point. Like it takes a long time with Q, I think it was Q learning.
mhm,
But it takes a long time in a lot of iterations. And
yeah,
then once it got back to the start, it basically started all over again. But every single iteration of that car then was based off of the winning car's initial lap. And then it just got better and better and
yeah,
better.
yeah,
So is that still under like it never jumps to a new model type? It always is considered um, whatever type of learning is initiated.
yeah,
Okay.
yeah, pretty much.
Interesting.
And so I don't look at like model based stuff as much.
Hmm.
And to be honest, like all this is new to me too. So like I'm still learning as much as I can.
Hmm.
But I know like with model based, there's a lot of things that you do like up front so that it doesn't have to have that like brute force way of learning where it's
Just throwing
yeah.
not actors, throwing agents at a wall. Yeah.
Yeah. Because like with do you know Alpha Zero?
I don't.
Okay. Um,
I don't think I do.
so AlphaZero is one of the model-based reinforcement learning
Hmm.
algorithms, but it's like a it. Yeah, let me look it up. So Google's DeepMind,
Hmm.
it's sort of like chess.
Is this
Um,
based off? Is AlphaZero Google?
Technically, I don't know if they
Because I've been
started as their
taking.
own thing and then Google and like absorbed them,
Oh yeah.
or but they're kind of like a spin-off of Google Brain or
Hmm.
something like that. I know that
Oh.
Google's related
Hmm.
at some point, but
Google's
basically
always
they
related.
yeah they trained an AI to play this game called Go,
Hmm.
um, and it actually beat. See the guy crying right there.
Yeah,
It
yeah,
actually
yeah.
it actually beat like the top person.
Hmm.
So I technically wouldn't be the best at like explaining the differences between model free and model based. I know that like model based in terms of like the like riding the bike example,
Hmm.
instead of like just getting on that thing and riding it and just trial and error. It's like you give it the information of like what a bike is and the physics of bikes
Hmm.
and a bike manual, and it's like it already kind of knows it, and then it
So
just like is exploring.
this was more possible because I guess the amount of combinations or the amount of things you need to do within this
Yeah,
model are
insane.
more quantifiable instead of like an open environment where it has to adjust the like in chess or in, I don't know what Go is, but in chess you can only have so many moves and so many reaction moves. So is it easier to do model based?
So the only thing that I know is model based is like insanely harder to do.
Oh, okay.
um
I guess you have to define every single
yeah,
potential move. Yeah.
yeah, yeah.
Hmm. Interesting.
I think that I've read like if you can do model based, then I think they even have it here. Let's see. Yeah, so this is kind of saying the main upside to having a model is that it allows the agent to plan by thinking ahead, seeing what would happen for a range of possible choices, and explicitly deciding between its options.
Okay. Yeah, but it
So
has to be able to predict the
it has
environment.
to have some sort of ground truth
Right.
model of the environment.
Hmm. Yeah. In a
Um,
lot of games, there's so many variables you can't really,
yeah,
or there's so many inputs you can't really decide that for them.
yeah.
Okay.
Um, but yeah, so I think we'll pretty much just stick over here with
Hmm.
like so policy optimization kind of incrementally directly being optimized. Q learning has this ability to go back to even past like more historical replays and learn from that. And then you have some models that have like a little bit of both. I
Hmm.
don't think so. CleanRL, I can pull up. So CleanRL only gives us the PPO, DQN, okay, C51, SAC, DDPG. Okay, so it does give us this one, but um uh trying to th I don't think it has HER or maybe even
Dude,
this one.
same.
uh but it
You
has
know
like a lot
what?
of them.
Sometimes I still think about her.
It's okay, Doug.
Yeah.
Um
Crying in the club.
oh my gosh. Cut that part out. Um
Why?
who is she?
Huh?
Do you want to talk about her?
Yeah. 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 She's Coursera right now.
The
She
only
makes
girl
me
that
cry
matters.
at 2 a.m.
But so CleanRL allows us to use most of these models. I think they even have like some variants. So you have like this PPO one right here. It has the PPO, but then it has like um, other things that so like PPO, LSTM. So LSTMs are really good for like sequential data
Okay.
and remembering data in terms of like time and remembering important features over time and forgetting features that don't matter as much to whatever you're trying to optimize.
Okay.
So a lot of people use LSTMs for like stock price prediction because it has like a sequential order,
Hmm.
or people use it with like language modeling because sentences, words, how words are like kind of structured has like an order to it.
Hmm.
Um, and then even with LSTMs, you can have variants of that and have things bidirectional. But it's not really needed to go over in this video.
Mhm.
But that's kind of all I had for this video. Hopefully you had a chance to have a better understanding or grasp of what reinforcement learning is. And I think in the next couple of episodes, I think it'd be good to like go pretty slow,
Yeah.
take
Is there
one
a
thing at a
specific
time.
type you'd want to study and implement in this
For
series?
these games.
Yeah.
I
Or
think
will it
D
be pick and choose?
I think either DQN or PPO, but because he has, all of these,
Mhm.
I don't see why we can't look at all of them.
Are we able to compare? Are we able to
Mhm.
run
Yeah,
different learning programs on the same game?
yeah. So
Okay.
from the first episode we did, I showed that website called Weights and Biases. So
Hmm.
um, that allows you to kind of sift through different models, different parameters, and it'll save all the results and the parameters and the files and stuff, and you
Okay.
can compare like how well it did.
Yeah.
Um, so yeah, we can look at all these. There's just a requirement of me kind of going into the details, studying, which I have to do this stuff anyways,
Hmm.
studying these algorithms to
You're
try
going to be a
to
doctor.
explain to you, common folk, what what is kind of going on without getting a little bit like too complicated. But
Yeah.
if we take it step by step, slowly but surely, um, and not every episode has to be like me talking and explaining something.
Hmm.
We could show the games because I mean we didn't
Yeah, I
do
was gonna
that.
say we can talk or you can explain stuff and the game can be in the background too.
Yeah, yeah, training, yeah,
Hmm.
exactly. But hopefully this was good. Hopefully you
Yeah.
have uh, a better understanding from now compared to the first episode, just like
Yeah, yeah,
what's kind of
especially different types of
going on.
models and that the feedback loop.
Yeah, and different models do different things, and it's
Hmm.
all an assumption of calculating mathematically what is the best way to learn something. And
Hmm.
that's all the differences between these models are. It's someone having some assumption or theory of, oh, learning should be like this,
Hmm.
exploring, exploiting, or learning should be like this, and it's something completely different. So like,
Right,
yeah, it's
right.
math, but like when you break it down, it's an assumption on learning. And a lot of times people look at how humans learn and try to mathematically like map
Mimic
that.
it. Yeah.
So
Hmm.
um, yeah, I think this was good.
Fair enough. Yeah.